Today's short tutorial is on density. Density is defined as the amount of stuff, mass, in a given space, volume. So density is defined as the ratio of mass to volume and can be written this way. Now here's the key takeaway that I want you to take away from this one. The ratio of mass to volume for a particular material does not change. Therefore, the density of a particular material does not change depending on the amount. So if I have 500 grams of gold, the density of that sample is the same as if I had 5,000 grams of gold. The units for density are grams per cubic centimeter, generally for a solid, or grams per milliliter, generally for a liquid. You'll see both in this particular course. As we said before, when we talked about intensive properties, density is an intensive property. It does not depend on the amount of material. You don't know how many times I ask that question each year and students classify density as an extensive property. It's not. It's an intensive property. We're going to show you that on the next page. Each year I ask a question regarding density and the size of an object. And the question could go something like this. I know the density of a large block of, let's call it aluminum. I cut that block exactly in half. What is the density for each piece of the aluminum block? And the answer is it doesn't change, but let's show you why when we do the math. Here's my aluminum block. I've measured the mass and it says 270 grams. I measured the volume and it's 100 times 1 times 1, so those are the dimensions, so the volume is 100 cubic centimeters. Remember, it's length times width times height. I go to my density calculation and there it is, mass over volume. I put in my values and I get 2.7 grams per cubic centimeter. So I'm going to write that right here, 2.7 grams per cubic centimeter. That's the density of this large block right here, right? So my question is, if I cut the block in half exactly, what is the new density for each block? And okay, so we're going to cut this exactly in half. So if I cut it exactly in half, my new block weighs 135 grams. Both of them. And why do they do that? Because 1/2 of 270 is 135. Right? Can everybody see how I got that? Here's my 270. I divided by 2 because I have 2 blocks now. Remember, I just cut it in half. And then what is my new volume? Well, the new volume is 50 centimeters cubed. Or 50 cubic centimeters. And why is that? Well, it was 100 cubic centimeters, but I cut it in half. So the volume has to be in half too, because I cut it exactly in half. Right? So now I just take those values and I put them into the equation, and lo and behold, I get 2.7. So the answer is 2.7. And that's for both of these. Each one has a density of 2.7 because they're the same. So the density doesn't vary with the size of the block because the ratio of mass to volume doesn't change. If the mass goes down by a factor of 2, the volume goes down by a factor of 2. The ratio doesn't change. That's why density is an intensive property. So hopefully nobody will get it wrong now that they've seen this little tutorial. Okay, so there's several ways that you can do density calculations, and it's based on rearranging the equation. So here's my general equation, right? And I can rewrite it several ways. If I wanted to find the volume is equal to the mass divided by the density. If I wanted to find the mass, it's volume times density, and therefore that's that. So if you know 2 out of the 3 parameters, you can determine the third. All right, so not always a question is always going to be, what is the density if I give you mass and volume? I might say, you have a density of 8 grams per cubic centimeter and a volume of 10 centimeters. What is the mass, right? And so you would have to rearrange your equation to do that. But the mass is just the volume times the density. Let's show you how that works on the next page. Here are some practice problems for various types of density calculation questions we could ask, right? And it's all based on that formula that D equals M over V, right? You substitute in the variables that you know and solve for the unknown, right? So the first one is just your straight density calculation. You know M and you know V, so therefore you can calculate D. In the second problem, it's asking for the number of grams, right? So you'd have to rewrite your equation, right? So if I want to know the grams, I want to know the mass. So if you remember, D equals M over V. So if I multiply each side by V to get rid of V on the bottom, I get V times D equals mass. And so that's what I'm doing here. I'm going to multiply 5.5 times this number, and it gives me that. Now in the last one, it says what is the volume if I had a mass of this and a density of this. Okay, here's my density again. And what is the volume? So if we did the equation, remember it's D equals M over V. Now I want to solve for V, right? So if I do everything as before, I see that V equals mass divided by D. And so when I do that, I get V equals this, right? I'm just rearranging the equation, right? Here's my density, here's my mass. What value under here, when I divide it into here, gives me this number? And that's the answer. So you just play with rearranging the equation in each case and then solving for the unknown. So that's it for density. You would now do some more practice problems on your own or the assignment which I've given you.